Hi everybody, this video is about how to find the inverse of a 2 by 2 matrix. But before we jump into inverses, we have to talk about the 2 by 2 identity matrix. So on the right side of the screen, I've written the 2 by 2 identity, but we have to talk about what that means. Well, it actually means exactly the same thing as when you heard the words additive identity or multiplicative identity in your first algebra class or a pre-algebra class. So if you remember, the additive identity, when you're just adding numbers, is 0, because 0 doesn't change. 5 plus 0, well, that stays 5. Adding 0 doesn't do anything. Well, if you do this matrix multiplication, and pause the video and practice your multiplication if you want, if I take 1, 0, 0, 1 and I multiply by this 2 by 2 matrix, I'll get the same 2 by 2 matrix. So multiplying by 1, 0, 0, 1 doesn't do anything. So this matrix is the 2 by 2 identity, which is sometimes called capital I. Now, what about inverses? Well, when you learn about inverses in some prior class, well, my earlier example was 5 plus 0 stays 5. Well, 5 plus negative 5 gets you back to 0, gets you to the identity. And that's what inverses are. So what we're going to try to find is, we want to start with the matrix 2, negative 5, negative 7, negative 3, and we want to multiply that by some matrix, and we want to end up back at the identity matrix. Now, here's a challenge. I'm not going to do it in this video because it would take way too long. But if you want, you could call this matrix ABCD, do the matrix multiplication. So you'd say 2 times A plus negative 5 times C equals 1. Okay, so you could do that for every term here. That means you'd have 4 equations and 4 variables. Really, that gives you 2 systems of equations, and you can solve the 2 systems of equations to find A, B, C, and D. It does take a while, which is why nobody wants to do it that way. So we'll skip to how you typically do this with 2 by 2 matrices in practice. You do 3 things, so I'm going to write them over here. Here's the 3 things that you do. You swap the 2 numbers that are on the main diagonal. You change the sign of the opposite diagonal. And finally, you divide by the determinant. So, if you haven't watched my previous video on determinants, you need to watch that one. So, some preliminary work, which as long as the numbers aren't too bad, you can do in your head. We need to find the determinant because we're going to need that as part of this process. So let's go ahead and find the determinant. So let's see, 2 times negative 3 is negative 6. Negative 5 times negative 7 is 35, and we're subtracting. So the determinant is negative 41. Now, we're ready to write down the 2 by 2 inverse. So let's follow the instructions here. You can do this in any order, it doesn't matter, that's why I didn't number them. You swap the main diagonal. So on the main diagonal, we have 2 and negative 3. So we're going to swap those 2 numbers, negative 3, 2. On the opposite diagonal, you change the sign of these 2 numbers. So negative 5 becomes positive 5, negative 7 becomes positive 7. So swap the main diagonal, change the sign on the opposite diagonal, and then you divide by the determinant. So we're going to multiply by negative 1 over 41. If you need to, for some reason, to actually do this scalar multiplication, you can. It kind of looks almost like a distributive property. You can multiply all the numbers by negative 1 over 41. Typically, I'm fine if you leave dividing by the determinant outside as a scalar. It looks a little bit nicer, but depends on what you're doing. So that's how you find the inverse of a 2 by 2 matrix. It's actually a really fast process. And you can verify, again, pause the video and do this, take this matrix in this, what do we call this, almost red color. If you multiply by 2, -5, -7, -3, now that wouldn't be a lot of fun because you have this 1 over 41 to deal with, but you would get 1, 0, 0, 1. You'd get the identity. So let's do one more so you can see how fast this process really is. All right, so we want to find the inverse of this 2 by 2 matrix. Well, first things first, let's find the determinant. We know we're going to need that. And in reality, as long as the numbers aren't too big, what most people do is they just do the determinant in their head. They think about it, and they'd say, well, that's going to be 30 minus 2, so that's 28. And then the process that I wrote on the prior problem, we swap the main diagonal, we change the sign on the opposite diagonal, and you divide by the determinant. There, you're done. And if you took this matrix in blue together with 1 over the determinant and you multiplied by the matrix we started with, you would get 1, 0, 0, 1. So really, finding the inverse of a 2 by 2 matrix isn't that bad. So that's the end of this video. Hope it helped.